In this video, we're going to talk about mole ratios. So what's a mole ratio? Well, a mole ratio is a ratio of two different substances involved in a chemical reaction. So in my example here, I have a 2 in front of sodium and I have a 2 in front of sodium chloride. So for every 2 moles of sodium, I will produce 2 moles of sodium chloride. So the coefficients in our balanced chemical reaction are equal to the number of moles. And as I mentioned, the mole ratio of sodium to sodium chloride is 2 to 2. So let's look at an example and let's see how we can use these mole ratios to determine either products or reactants in a chemical reaction. So the question says, how many moles of NH3 can be produced from 4.3 moles of nitrogen, N2? So just like before, we're going to write out what we're given first. So we have 4.3 moles of N2. Now notice when I wrote out my moles, I included the N2. When we do mole ratios, we want to make sure that we specify what we're dealing with, because moles of nitrogen and moles of NH3 are both moles, but they're not moles of the same thing. All right, so let's find N2 and NH3 in our reaction. So there's like an imaginary 1 in front of our N2, and we have a 2 in front of the NH3. So we're going to still follow the same rules that we were for conversions. So our units are moles of N2. So in our denominator, we're going to need moles of N2. So for every 1 mole of N2, we have 2 moles of NH3. So here's what I did. I took the 1 from here and the 2 from here. So my units are going to cancel. My moles of N2 are going to cancel with my moles of N2. So if I did the multiplication here, I would have 8.6, and my units will be moles of NH3. We have 2 sig figs in our original answer, and we have 2 sig figs in our final answer, so we're good. All right, this is the second part. We're going to be still using the same reaction. It says, how many moles of H2 are needed to produce 1.75 moles of NH3? So let's start by writing out what we're given. 1.75 moles of NH3. So we're looking at NH3, and then we're looking at hydrogen. So let's circle the coefficients involved. We have 2 and 3. We want to make sure that our units that we start with go in the denominator. So for every 2 moles of NH3, and that's coming from right here, we have 3 moles of H2, and that's coming from right here. So what's going to cancel? Well, moles of NH3 are going to cancel. When we plug this into our calculator, we get 2.625, and we had, let's see, this is 3 significant figures. So we want 3 significant figures in our final answer. So going from left to right, let's underline the first 3 significant digits. And then we'll look at the fourth. So is this going to be 2.62 or 2.63? Well, it's going to be 2.63, and our units are moles of H2. So in this example, we started with a product. We started on this side of the reaction, and we were looking at something on the reactant side. It doesn't matter which way you go, as long as you're following the same rules. All right, here is a different reaction. How many moles of magnesium can be produced from 1.7 moles of aluminum? So let's start by writing out what we're given. 1.7 moles of aluminum. So we're looking at aluminum and we're looking at magnesium. We have 2 moles of aluminum, 3 moles of magnesium. So for every 2 moles of aluminum, we have 3 moles of magnesium. The units of moles of aluminum will cancel. 1.7 times 3 halves gives us 2.55. We have 2 significant figures in our given number. So we want 2 significant figures in our final answer. Going from left to right, let's underline the first 2 significant digits, and then let's look at the third. So in this case, we're going to round up to 2.6, and then our units will be moles of magnesium. All right, I'm going to throw you a little curveball with this final problem. Same chemical reaction, but this time it says how many grams of aluminum are needed to produce 7.27 moles. We've been going from moles to moles. This time it's asking us to go from moles to grams. So what's that going to look like? Well, let's start by writing out our given, 7.27 moles of magnesium. And we can't go directly from moles of magnesium to grams of aluminum. We have to first go to moles. We have to do a mole ratio, kind of like what we were doing. So we need to go from moles of magnesium to moles of aluminum. So for every 3 moles of magnesium, we have 2 moles of aluminum. Now we're going to need to add one more step on, because right now all we've done is we've converted from moles of magnesium to moles of aluminum, and it wants grams. So if you look up the molar mass of aluminum, 1 mole of aluminum has a molar mass of 26.98 grams of aluminum. So the moles of aluminum will cancel. We multiply this out, we get 130.763. We have, let's see, that's 3 significant figures. So from left to right, let's underline the first 3 significant digits and then look at the fourth. So we're going to go ahead and round this up to 131. We don't need a decimal here. If we included a decimal, it wouldn't change anything because we're not ending in a 0. So 131 grams of aluminum. This is actually going to lead into our next lesson, where we are going to be converting from grams of one substance to grams of another. But that's a video for another day.